This is 1982 IMO problem number 4, and here is a view of this problem. We would like to show that this equation, if it has a solution in integers x and y, then it should have at least two other solutions, okay, also in integers. Okay, that's the first part, and for the second part we will show that when n is replaced by 2891, this equation has no solution. Okay, let's start with the existence. The first part, part A, which is just an algebraic manipulation type of argument. X cubed minus, consider the left hand side, xy squared plus y cubed, and you want to make it equal to n. Right? It turns out that it's possible to express this expression in the following way, and I leave it to you as an exercise to check that it really works. A minus 3 times, and you see where I'm going from this, times, hold on. So what I'm doing here, as you can see, I'm replacing x with this guy. This one is replaced, so I still need to have that one. And it turns out that the second one is just x. So therefore you have an x squared here, plus, and for the, no, it's not x. It's minus x, my bad. It's really minus x. Okay, there you go. Square plus minus x cubed. Can you please confirm that this identity is indeed true? Because if it is, then all I'm doing is replacing x with y minus x and replacing y with minus x, and boom. So if xy is a solution, then so is y minus x minus x. But it turns out I can do more, and it turns out that this thing is also equal to minus y cubed minus, again, 3 times. That one was minus y, and the y term would become x minus y square, and it just actually follows directly from symmetry. I don't know, it's like I think it's pretty much the same thing. Yeah, it's nothing fancy here. Okay, so please confirm that this one is also true. So in that case, we're further replacing them with replace x and y with replace x with minus y, and replace y with x minus y. Does that make sense? So therefore, if xy is a solution, then so is minus y, x minus y. So therefore, if xy is a solution, we have two other solutions as well. Okay, now the second part. In the second part, we have n is replaced by 2891, and we would like to show that no such solution exists. In that case, x cubed minus 3xy squared plus y cubed. You have this Diophantine equation, and we need to show that no integer solutions for x and y are possible in this case. Well, it kind of it's almost immediate that you would have to try some different mods. I can try mod 3 actually. When I do when I investigate this in mod 3, it turns out that this term, the middle term, vanishes. So it would imply that it's equivalent to x cubed plus y cubed is congruent to 2891. So this is 10 is it 89? Yeah, 89 is 17, so 10, 27. Yeah, so this is a 2, babe. Or if you will, you can write it. Well, depends. I will make use of both of them, actually. How about that? Okay, so when would that hold? Well, we have a few case work to consider. I claim that we have 3 cases. Well, 2 of them are symmetric to each other, obviously. But, okay, either x is congruent to minus 1, and y is 0, right? So when you cube it, you get minus 1 here, cube 0, and then you get minus 1 for the total, right? The second case is the opposite, so that's why I said it's almost symmetric. The only difference is the third case, which is x and y are both congruent to 1, x cubed, y cubed, it adds up to 2. Let's investigate, let's say, the first case, and let's show the impossibility for the first case. It would imply immediately that the second case is also impossible because of symmetry. So if x is minus 1 in mod 3, that would mean that x is equal to 3m minus 1, and y is equal to 0, meaning y is equal to, say, 3n. And let's just substitute these two expressions into here, and let's see if it I meant to say, sorry for that, I meant to say let's substitute them into our original expression, because we know they should satisfy this one, right? Because this is how we got those. So let's substitute them into our original expression. Yeah, so into this guy, right? And let's see if we get something meaningful. If we can get 20, and when we set it equal to 2891, we can get something meaningful, right? So when we do so, let me be careful here. So I have 3m minus 1 cubed minus 3 times 3m minus 1 times 3n, and then 3n cubed plus 3n cubed, and I want to set this equal to 2891. I won't bother making the calculations. All I will do is I will this time look at mod 9. In mod 9, this one is 1020, so this one is a 2 on the right hand side, right? So this is congruent to 2 in mod 9. Look at this, 3 3s. Sorry, forget about this one. This one's 3 times 3, this is a 9, so this one vanishes. 3 cubed is 27, this term vanishes. So all we need to check is this one, 3m minus 1. So and obviously you can really easily check it, that and you will see that there's no way that you will get a 2 here, right? For instance, 3m minus 1 is equal to in mod 9, right? So it's either 2 or it is 5 or 8, right? So 2 cubed is 8, it's equal to minus 1 in mod 9. 5 cubed is 125, oh boy. Or let's say 5 squared times 5, so 5 squared 25 in mod 9 is what, minus 2 times another 5 minus 10, so minus 1, again that won't work. And finally 8 cubed, right? 8 times 8 is 64, it's 1 mod 9, and then times 8, it's 8 mod 9, which is minus 1 again, so that won't work either. I think I'm high. I should have known that. But anyhow, well, all these gave me the same thing. Shoot. Okay, but fine, right? So that case is impossible. That case is impossible also. So that leaves us only a single case, right? So, and let's have a look at quick check this case. Well, this case, the impossibility of this case follows from the fact that, hey, when xy was a root, this was also a root, right? So this would imply also a solution. So that would imply that 1 minus 1, which is 0, and then minus 1, 0 minus 1 is also supposed to be a solution. But what's wrong with that? Oh, that's wrong. This is wrong. Look at this, 0 minus 1. So this boils down to this case, which is already impossible. So if this is a root, this was supposed to be a root, but we just showed that this is not a solution, so therefore it's impossible. This wasn't supposed to be a solution in the first place. So therefore, whenever this whole expression is equal to 2891, there is no solution when n is equal to 2891, and that solves our problem. And hope to see you guys in our next lecture.